My name is Raquel de Souza. I'm an associate lecturer at the Department of Mechanical Engineering, and I'm here to talk about the subject dynamics. So dynamics is a core subject for the Master of Mechanical Engineering and the Master of Mechatronics Engineering. Dynamics is about moving things. More specifically, is about moving rigid bodies. A rigid body can be a golf ball or a spinning top rotating on a table, and we analyze the movement of these rigid bodies and these systems, these mechanical systems, and we want to understand how they are moving. So if we know how the system is moving, we can predict the movement and we can analyze the movement. And this is important in the design process. If I know how the forces and the stresses are acting on the system, I can choose the materials, I can choose the components of the device that I want to design, for example, to use in the device that I'm trying to create.
In dynamics, we will be more trained and taught in the ability to solve a problem instead of pure abstract theories.
You get to learn very powerful techniques on how to analyze things that move. So anything that moves, essentially, from aerospace to robotics to whatever. The things you learn in the subject are really applicable to a wide range of engineering applications.
We use dynamics to model systems in three-dimensional space. So this is more realistic cases that you would do in maybe undergraduate subjects. We don't do it only on paper. We actually measure a device and we analyze this device and we create a virtual model of it using the models that we learn in class, and we can create a virtual copy and see that they actually predict and show the movement.
At the end of the semester, the work you learn culminates in a lab report where you get to analyze the gyroscopic precision of the gyroscope, which is really cool because you're applying these very abstract concepts and getting to see how they essentially look and behave in somewhat real life.
In dynamics taught us not only a systematic way, but also some useful tools in group work. We also made a 2-hour guest lecture for us to give more insights on how to perform group work more properly.
Dynamics is different than all the subjects because we do it in 3D, so it's more realistic and more interesting. And we don't do it only on paper. We actually measure a device and we create a virtual model of it, and we apply our models and we see that it actually predicts and shows the movement of this real device. Any student interested in mechanical systems and how things are moving would be interested in this subject.